Hello my dear wonderful genius students, I'm back again with a new video. This is lecture number 4 on complex analysis. Today I'm going to teach you de Moivre's theorem. This is also a very simple theorem, and according to this theorem, cos theta plus iota sin theta whole to the power n equal to cos n theta plus iota sin n theta. This theorem is valid for any value of n. That means this n can be a positive integer or a negative integer or any fraction. Now let us derive this theorem. Students, we can derive this theorem with the help of Euler's formula. In my last video, I told you that the Euler's formula is cos theta plus iota sin theta equal to e to the power iota theta. If we take nth power on both sides of equation 1, we get cos theta plus iota sin theta whole to the power n. It's equal to e to the power iota theta whole to the power n. Here, n can be a positive integer or negative integer or any fraction. Now, e to the power iota theta whole to the power n can be written as e to the power iota into n theta. Now, let us apply Euler's formula to this expression. That means e to the power iota n theta. If we apply Euler's formula, we can write cos n theta plus iota sin n theta. So, we have seen that cos theta plus iota sin theta whole to the power n equal to cos n theta plus iota sin n theta. So, prove. Now, let us solve some problems by using de Moivre's theorem. The first problem is cos theta plus iota sin theta whole to the power 5 equal to how much? So, if we apply de Moivre's theorem, we can write cos 5 theta plus iota sin 5 theta. Next question is cos theta plus iota sin theta whole to the power minus 5. So, if we apply de Moivre's theorem, we can write cos minus 5 theta plus iota sin minus 5 theta. Cos minus theta equal to cos theta. So, after simplifying, we can write cos 5 theta. Again, sin minus theta equal to minus sin theta. So, this expression will become minus iota sin 5 theta. Next question is cos theta plus iota sin theta whole to the power 5 by 2. So, if we apply de Moivre's theorem, we can write cos 5 by 2 into theta plus iota sin 5 by 2 into theta. Okay? Now, let us do another problem. The question says that we have to prove cos theta plus iota sin theta whole to the power 4 divided by sin theta plus iota cos theta whole to the power 5 is equal to sin 9 theta minus iota cos 9 theta. If you try to solve this problem, you will notice that you can apply de Moivre's theorem to the numerator part directly, but you cannot apply de Moivre's theorem to the denominator part directly. However, there is a trick to solve this type of problems. Now, let us solve this problem by using that trick. We know that cos theta plus iota sin theta is equal to e to the power iota theta according to Euler's formula. E to the power iota theta whole to the power 4. Again, sin theta plus iota cos theta can be written as iota into e to the power minus iota theta. Iota into e to the power minus iota theta whole to the power 5. Again, we know that iota to the power 5 is equal to iota. Okay? E to the power iota 4 theta, iota into e to the power iota into minus 5 theta, 1 by iota. these two parts can be written as e to the power iota 9 theta. Next, apply Euler's formula for this expression e to the power iota 9 theta. But before doing that, let us multiply numerator and denominator by iota. If we do, then we will get minus iota. Next, apply Euler's formula cos 9 theta plus iota sine 9 theta. Let us multiply this expression by minus iota. If we multiply, then we will finally get sine 9 theta minus iota cos 9 theta, which is the right hand side of our problem. Right hand side. Proof.